Okay, so the backup camera was like, it was mostly just like integrating car safety features, like advanced car safety features into older cars. And we ended up not doing that because there was a lot of companies that had already like designed that and done like really good like products and released them to the market. And we just wouldn't have been able to do it for cheaper than they had.
Several areas around campus that exhibit safety issues. Mostly just busy students in passing periods that really want to get to class quickly, or they're Snapchatting, whatever, just not paying attention. So we really wanted to kind of bring the issue to light, even though it's not actually consciously on their mind why it's slowing them down.
We noticed that especially with like new boosted boards and electronic scooters, people tend to go really fast and they stop paying attention to what's around them and just kind of have the goal of getting to class without paying attention to pedestrians that they could potentially hit.
Personal transportation technology has greatly improved, and these developments have compromised the safety of other pedestrians, especially in congested areas around college campuses. We want to reduce accidents and near misses in narrow areas or blind corners without bringing the flow of traffic to a complete stop.
We did a lot of work to test where we wanted to implement this design, and that helped us a lot to figure out what we wanted to do for our design. We tested out certain areas around campus to try to figure out what we could do in terms of making things safer. I think that helped us to understand what we wanted to do overall.
So we kind of began our problem with a bunch of different areas that we thought we could do. And so we kind of just started with those and then eventually just worked it down to one specific area that we wanted to focus on campus.
Initially we wanted to make it linked, different sections so that it could pivot around corners or just angles if we needed to. And then we realized there wasn't really a good way to do that without leaving awkward gaps that cause tripping hazards for small skateboard wheels. So we just made one single long one instead that could still be linked, just not angled. The actual changes. Well, at first it's going to be 3D printed, found out it was too big and too expensive.
And then the 3D printing just kind of got shot down by Mo when we talked to him about it. He was like, yeah, it's not feasible, it's not cost effective.
And then it was going to be some combination of wood, plexiglass, and metal, and then it ended up being just wood because it was the most budget-friendly, time-conscious, but still effective means we came up with.
Well, there wasn't really a lot of electronical stuff until we actually settled on our final pressure sensor and everything. So that didn't really come into play until a little later in the project. Researching and like knowing things, finding out things like on the internet and figuring out what exactly we needed to do, like what specific pressure sensor we had and how it should be wired. Especially when we tried to wire 2 pressure sensors and trying to figure out how I was supposed to do that.
Well, we started off, we wanted to use the Pixie camera, and we never even began with the software side of things because it would have been a mess.
Then we just decided the Pixie wasn't useful for our the requirements that we needed it for.
And then as we progressed to like the pressure sensor, we ran into problems getting the software to work with the hardware. But after debugging it for a really long time, we finally just got it to work.
So the software started as just trying to get the one sensor working and reading the pressure, and after we found out like what the stable pressure was, then we moved into like trying to figure out timing, and Mo is a huge help on that, giving us a lot of suggestions. And then overall it was just this really like back end way that we solved the coding problem, and it ended up being like a on-off switch that we would set depending on how much time it elapsed between pressure spikes.
For this project, I didn't think it was too much of a problem because James and I were working on the software side of things, and we don't really have to be together to do that. We could just send each other what we've been working on. So it wasn't much of a problem for what I was doing, but I can imagine it being a problem for the manufacturing side of things.
So for working outside, you know, we had a lot of things that we could just do on our own, that we didn't really need to be with each other. We could use communication outside of class, such as we used the GroupMe app to text each other, and that was really helpful when we needed to just talk about what we're working on at that moment.
Oh, James is our fearless leader over here. He pretty much delegated who was doing what and really made sure that we knew what the tasks were.
Yeah, with communication we were pretty good, talking about like what we needed to do, understanding where we were generally in the project, and I think we did a really good job of helping each other and distributing the workload.
I think our team just kind of, for this team specifically, we kind of just fell into our places, and we chose our own like positions, and it just kind of worked out to fit our skill sets. But for other teams, I think it would definitely be more of a challenge, and you would have to like ask people what they wanted to do and like find those skill sets rather than just having it like work out the way that we did.
I think I learned a lot about teamwork and working with other people, and then also the software side of things. I came into this class not knowing anything about computer software, and I'm leaving knowing more.
Communication would probably be the biggest one because I'm kind of a lone wolf. a lot of times I just kind of do things that I know need to be done instead of actually organizing with people, and having to know what I'm doing at the same time as somebody else is doing, so that way we're not doubling up on tasks.
I think I learned a lot about prototyping and creating the project with 3D printing, or trying to 3D print the speed bump beforehand. It helped me to learn how to set it up and everything. And then I also had a lot of control over the electronic part. And I learned a lot about how the electronics and the actual manufacturing of the project work.
I think I learned quite a bit working with Tyler on the manufacturing side. Learned a lot about different saws and different types of things to cut wood and do a bunch of things with that. I also feel like I learned a lot about graphic design, I guess, with making the poster, and learned a lot about technical writing.
I'm really proud of how we work together and our cohesive goal mentality that we had, and how we all just kind of came in, had a good attitude, and worked towards the goal at hand, and we helped each other out. And whenever one of us got stuck, the others would be willing to jump in and help in any way that they could, and we all just worked to get the project done.
I think we all communicated with each other really well. We all understood what we needed to do, and if we ever needed help, everyone already understood that, and we distributed work pretty well between each other.
I think we all countered each other really well, and we just had people working on manufacturing and then the software side of things, and we all just came together really well.
I'm really proud of our team for pulling it together for finally at the expo. It's awesome that they got the programming working and everything just going, and it was really cool that we had a working, finished project at the expo.
I'm most proud of the team's effort. Everybody kind of came together and really pulled through at the end, so it was more so we didn't have any one weak link. Everybody just kind of knew what they had to do and they got it done, and everyone delivered.
Maybe start prototyping earlier and really just figuring out what problems we're going to have later down the road earlier, so we just have more time to work on them.
I think we could spend a little more time working out the design process and understanding what we needed to do and what we wanted to do, because with things like the Pixie, we didn't fully understand what it could do. And I think if we did have a better understanding of that, then we could have had an earlier start on the building stage.
I think that our team was set up really well, as other people have been saying. We really knew our place and everything. Everyone had something to do, or everyone knew what they should be doing. No one really had to say, you do this, you do this, you do that, which was really good. And then for the design process, I think, yeah, we did spend a lot of time on planning and less prototyping, and I feel like if we had more time to prototype, or had set more time to prototype, that could have been really helpful.
I would do more workshops, because I knew zero coding or any real electronic stuff other than how wires work. But I would for sure do workshops and really kind of make a more complicated project instead of just a really simple function.
Design process or team management? I would probably spend less time planning and more time prototyping, because I think that we just kind of ran out of time near the end because we spent too much time prototyping, and the planning didn't really help us in too many ways. I think we had a couple of days of effective planning, but after that it just ran out.
For my own abilities, I came into this class not really thinking I was going to like programming or anything, but now I actually really enjoy it. So yeah, I learned that about myself.
I think I gained a little bit more of an understanding of what I know and what I'm able to do, and just my general skill set. So for future reference, if I need to know how to wire something, or a sensor or something, then I'll know how to do that.
I don't think it really changed my perception of engineering because I believe like engineers are here to like solve problems, like look at the world, see problems, and then solve them, and that's basically what we did in this class. So I feel like it was just like emphasizing engineering.